Let's take a look at one last example. This one's a little bit more complicated, so you'll want to pay particular attention. From a certain distance from a flagpole, you notice the angle of elevation to the top of the flagpole to be 48 degrees. When you walk 36 additional feet from the base of the flagpole, the angle of elevation to the top of the flagpole is 32 degrees. I'd like to know how high is the flagpole. Like I said before, this problem is quite tricky and by far the hardest problem in the section. So first we're going to draw a diagram and label what we know and what we're looking to compute. So I drew the setup, where the X is, that's the flagpole. The angle of elevation to the top of the flagpole is 48. Then we walk 36 more feet away, and the angle of elevation to the top is 32. So you'll notice the smaller triangle, I labeled the base with an A. We're going to need to do that, and we're going to need to find that in order to solve for X. So what I'm going to do is I'm going to use tangent a couple of times. So one of the things I know is the tangent of 48 degrees is x over a, the opposite over the adjacent. And I know the tangent of 32 is x over a plus 36. So what I did is I took each of these equations and I solved them for a. So on this first one I did a little cross multiply and division, end up with a equals x over tangent 48. On the second one I did the algebra out. If I cross multiply, I end up getting tangent 32 degrees multiplied by a plus 36 equals x. And then what I did was I distributed, so I had a tangent 32 plus 36 tangent 32 degrees equals x, and then I solved for a. Subtracted the 36 tangent 32 degrees and divided by tangent of 32 degrees. Now, because I'm going to solve this, I'm going to take these two things that I solved for a and set them equal to each other. What that's going to allow me to do is solve for x. So when I set them equal to each other, here's my setting equal, I again cross multiplied. So x tangent 32 is tangent 48 times x minus 36 tangent 32. So there that is. And then I distributed, so I'd have x tangent 48, and then I'm going to have 36 tangent 48 tangent 32. And I could put those in my calculator, but I really don't like rounded numbers, so I'm going to keep carrying them along. Plus, you'll be able to see where the numbers came from. Now I'm going to solve for x, and this is a little tricky. So to solve for x, I put everything with x's on the same side of the equation. So what I did was I took the x tan 32 and moved it to the right, and I took this negative term and moved it to the left. Now I have both x's on the same side. I'm going to factor out an x, because both of these have an x, and divide. And so there's what I get as my expression, and when I do the division, I get 51.43 feet. So if I go back to my picture, what I now know is, is the height of the flagpole. I know the x, that's what I just found. I know the x, and the x is now computed, and it actually asks me how high the flagpole is. If I wanted to now, I could actually go back and substitute in this x. It'd be a little bit rounded, but in for a, and I'd be able to, or in for x, and I'd be able to solve for what a is. Kind of a neat question, but one that you probably really want to sit down and kind of chew on, because it's not terribly easy.